morning, student. This is Sandhu who will be working as Assistant Professor in Department of Mechanical Engineering in MBA College of Engineering and Technology. In this session, we are discussing about the problems on design of the cylinder. In the last class, we have discussed one of the problem of design of the cylinder. This is the next problem. See carefully. It is very important problem. As I told in the last classes, if you are having data book, please keep with you the data book. It is very useful because the formulas are also available in the data book also. Okay. See, following data refers to the four-stroke petrol engine. Brake power is equal to 7.5 kilowatts. Engine speed is equal to 1200 rpm. Indicated mean effective pressure is equal to 0.45 Newton per mm square. Maximum explosion pressure is equal to 3.2 Newton per mm square. Mechanical efficiency is equal to 80%. Allowable stress for CI cylinder is equal to 40 megapascal. Allowable stress for M9 steel bolts is equal to 70 Newton per mm square. Okay, first what they had given in the given data. First they had given the 4-stroke petrol engine. Okay, brake power is equal to 7 means BP. Okay, engine speed N is equal to 1200 rpm. Indicated mean effective pressure PM. Okay, P suffix M. PM is equal to 0.45 Newton per mm square. Maximum explosion pressure P max. Okay, P max is equal to 3.2 Newton per mm square. Mechanical efficiency is equal to 80%. Allowable stress for CI cylinder. Allowable stress is indicated as sigma. Means sigma suffix allowable is equal to 40 megapascal. Allowable stress for Ni steel bolts is equal to 70 Newton per mm square. Means sigma allowable for Ni steel is equal to 70 Newton per mm square. Okay. Determine first one. What should we find out? First one. The bore and stroke of engine with L by D is equal to 1.25. Okay, that is 1.25. The thickness of cylinder wall and flange. Third one, the size and number of bolts required to connect the cylinder head. Okay, what they had given in the given data. First one, brake power is equal to 7.5 kilowatts. 7.5 into kilo is nothing but 10 to the power of 3 watts. Engine speed N is equal to 1200 rpm. Okay, we can find out the number of strokes. What is the number of strokes they have given in the question? 4-stroke petrol engine. 4-stroke petrol engine is nothing but petrol engine. Okay, we should take N is equal to N by 2. Okay, 4-stroke. Okay, they have given the 4-stroke because we will take as a N is equal to small n is equal to capital N by 2. N is nothing but 1200 rpm. Okay, small n is equal to N by 2 is nothing but 1200 by 2 is equal to 600 cycles per minute. Okay, Pm is equal to 0.45 Newton per mm square. Okay, we have to convert into the meter square. That's why we should take into 0.45 into 10 to the power of 6 Newton per meter square. T max is equal to 3.2 Newton per mm square. Okay, mechanical efficiency is equal to 0.8. Allowable stress is equal to 40 Newton per mm square. Allowable stress for bolts means sigma B is equal to 70 Newton per mm square, where L by D is equal to 1.25 D. Okay, where L by D is equal to 1.25. First one, what should we find out? We should find out the first, what should we find out? We should find out the cylinder bore and stroke. Okay, cylinder bore diameter and stroke. Okay, for a given CI engine, L by D is equal to 1.25. Then N is equal to 1.25 into D. As we know that dP is equal to PMLAN by 60 into 1000. This is the formula. Into mechanical efficiency also they have given into mechanical efficiency. PM into L we can write it as 1.25 into D. Area we will calculate as 5 by 4 D square. Small and number of strokes they had given us 600. Okay, by 60 into 1000 into 0.8. Okay, 0.8. Okay, BP they had given us 7.5. Okay, 7.5 is equal to B mass one pressure 0.5. Then you can simplify this value. Okay, then D cube is equal to how much you will come? 2.122 into 10 to the power of minus 3. Then you will get the D value as 130 mm. If you have D value, substitute in this D value in this L, you will get the L value also. Okay, then next second one. Second one, what should we find out? Second one, we should find out the length of the cylinder. Okay, L say it is a petrol engine. In the question, they have given four-stroke petrol engine. Means assume compression ratio as 6. This is available in the data book only. Okay, assume compression ratio as okay, clearance ratio as 6. Okay, what is the formula for the clearance ratio? Clearance ratio is equal to swept volume plus clearance volume by clearance volume. As you know that this is the formula from Narendra Singh Congress yesterday. Clearance ratio. Clearance ratio is equal to Vs plus Vc by Vc. Okay. Vs is nothing but a swept volume. Vc is nothing but clearance volume by clearance volume. Okay. Swept volume. Swept volume means what? Where the swept volume will be indicated as is nothing but in the stroke, where the from the cylinder to piston the power will be generated, where that is the stroke values. Okay, number of strokes will be calculated. Okay, like this is nothing but swept volume, we can take it as stroke plus clearance volume is where it is applied at the top of the center, means top clearance by clearance volume is equal to, then see our clearance ratio is equal to, we can write it as L plus L1 by L1. Okay, clearance ratio there we are taking as 6. L we had find out. We had find out that the value is nothing but 163 plus L1 by L1. Simplify. 6L1 is equal to 163 plus L1. Okay, 6L1. Bring this L1 that side. You will get the 5L1. 5L1 is equal to 163. Then L1 is equal to how much? 32.6 mm. Okay, next length of cylinder. We should calculate the length of cylinder. Length of cylinder means is nothing but we will take it as stroke full length. We should take the full length from the top position to the last position. Okay, it is nothing but stroke plus top clearance plus piston length. Okay, piston length. Then L plus L1 plus LP. LP we can take it as 1.25 into D. Okay, L we have found out as 163, L1 32.6, LP 1.25 into D. D value is nothing but 130. Substitute we will get the length of the cylinder. Okay, this is the value. What should we find out? We should find out the length of the cylinder. Okay, how we will calculate the length of the cylinder from the top position to bottom position of the cylinder we should calculate. Okay, suppose we are taking as compression ratio as 6 because it is a petrol engine. Okay, then clearance ratio is equal to swept volume plus clearance volume by clearance volume. Swept volume we can take it as stroke. Clearance volume we can take it as top clearance by clearance. CR is equal to L plus L1 by L1. Simplify, you will get the L1 and also length of the cylinder also you will get. Okay. Next, third one we should calculate the thickness of the cylinder T. Okay, assume allowable constant C is equal to 4 mm. Okay, thickness of cylinder wall is. What is the formula? If you see in the data book only, directly they will give you the thickness of the cylinder formula. Okay, T is equal to P max into D by 2 sigma allowable stress plus C. Okay, P max already they have given the value 3.2. D we find out 130. 2 into allowable stress also in the question they have given 40 plus C value we are taking as 4. Okay, simplify, you will get the thickness of the cylinder. T is equal to 10 mm. Okay, these formulas directly will be in the paper book. Don't be confused. Okay, next fourth one, thickness of cylinder flange. Thickness of cylinder flange, we can take it as a curve. Thickness of the cylinder flange TF is equal to 1.3 into T. 1.3 into 10. TF is equal to, we can write it as 13 mm. Okay, next thickness of cylinder head TH. TH is equal to KD root of P max by allowable stress. K. K is nothing but 0.35 into D. Diameter is nothing but we find out as 130. Maximum pressure. In the question they have given 3.2. Allowable stress 40. Then TH is equal to 13 mm. Okay. Next, number of studs. Number of studs we can take it as N. Okay, N. Number of studs means what? If we are fixing for the cylinder at the top position, two types of the bolts. For to fix the bolts, the studs are important. Okay, it is in the range of 0.01 D to 4 NS. NS we should find out. NS how we will find out? 0.01 D plus 4. Substitute the D value, you will get the NS. Okay, next, just take capital N is equal to 6. Next, diameter of studs. Diameter of studs means ds. The core diameter of studs is given by dc is equal to d root of p max by n sigma tb. Okay, dc is equal to d root of p max by n root sigma tb. 130 into 3.2 by 6 into 70. Substitute all the values that they have given in the question. Diameter we find out, maximum pressure they have given in the question. N we are taking as 6, and we are taking as 6, and also allowable stress for bolts also we have taken. Okay, what is the here? N is means N is not the speed. Okay, here N is nothing but the number of studs. Okay, number of studs value we are taking. Okay, now the nominal diameter here illustrates two types we will find out. One is the diameter of bolts studs, and also the diameter of studs. Okay, outer diameter of studs also we will find out. The nominal diameter of studs is dB is equal to dc plus dc by 0.84. The DC already we find out. Core diameter of structure. Core diameter of structure already we find out 11.34 by 0.84 is equal to 13.5 mm. Okay, see, the nominal diameter of stud should not be less than 16 mm. Means dB is equal to 16 mm. Next, diameter of stud pitch circle and flange. Diameter of stud pitch circle and dp and flange do. The diameter of stud pitch circle is dp is equal to d plus 3 db. Okay, 3 db. Substitute all the values, you will get the dp value. Okay, here what we find out? We are find out in the number of diameter of stud pitch circle and flange. Okay, next, the outside diameter of flange is d naught is equal to dp plus 2 db plus 12. Okay, substitute all the values. Why we are taking the outside diameter of the flange? Flange means what? Here at the top position we are fixing the we are for the bolts we are fixing the flanges. Flanges means to support the cylinder. To support the cylinder, we are taking the flanges. Once you recollect in the DMM1 also we have discussed about the flanges and hub. Okay, like that only same. This is also that same position of the flanges. Okay, to support the cylinder, we are fixing the flanges. Okay, here we outside diameter of the flange we are calculating, means DO. DO is equal to dp plus 2db plus 12. Okay, dp is nothing but pitch diameter. Okay, pitch diameter plus 2dp, bolts diameter or struts diameter plus 12. Okay, this is available. This how should be taken means this is available in the data book only. Okay, substitute all the values, you will get the outside diameter of flange is nothing but 222 mm. Okay, next pitch for studs. Pitch for studs is nothing but the pitch of stud is PBO is equal to pi dp by n. Pi dp by n is equal to pi into 178 by 6. PBO is equal to 93.2 mm. Okay, the maximum and minimum permissible values of pitch are PBO minimum is equal to 19. This is also available in the data book only. Just you write the formulas, so then you will get the PBO maximum means pitch for studs, maximum pitch and minimum pitch. It should be greater than or less than values. Maximum should be higher and the minimum should be low value. Then only the pitch of the studs is satisfied. Okay, this is the one of the model of the design cylinder. See, uh, again I will discuss the problem. See, this is the given, and this is the given problem they had given. Already we have studied. We should find out the bore and stroke of engine, thickness of the cylinder wall and flange, size and number of bolts required to connect the cylinder head. Okay, like that we should find out the stepwise. First, what should we find out? We should find out the brake power. The brake power. We in the question they have given the brake power. dp is equal to 7.5 kilowatts. Speed they have given. We will find out the small n, maximum pressure, mean effective pressure, mechanical efficiency, allowable stress they have given sigma AL, allowable stress for both sigma B they have given, where L by D is equal to 1.25. We can write it as L is equal to 1.25 into D. Okay, first one they had given cylinder bore and stroke. Okay, for a given CI engine, L by D is equal to 1.25. Then L we can write it as 1.25 into D. Okay, now brake pressure, power is equal to, we can write it as PMLAN by 60 into 1000 into mechanical efficiency. Substitute all the values. Okay, substitute all the values means L we can write it as 1.25D, A we can write it as 5 by 4 D square. Then you will simplify. Then you will get to the D value. Okay, D is equal to how much? 130 mm. If you keep the D value in this L in that equation, L is equal to 1.25D, you will get the L value also. Okay, next second one, what should we find out? We should find out the length of cylinder. Length of cylinder means here in the question they had given the petrol engine. Petrol engine means assume it is a petrol engine, assume compression ratio as 6. Okay, how we will take clearance ratio is equal to compression ratio, clearance ratio. Clearance ratio is equal to swept volume plus clearance volume by clearance volume. Swept volume we can take it as a stroke. Clearance volume is stop clearance volume by clearance. Okay, now here compression clearance ratio is equal to, we can take it as L plus L1 by L1. Okay, substitute all the values, then L1 is equal to 32.6 mm. Okay, next length of cylinder. Length of cylinder LC is equal to stroke plus top clearance plus piston length. Then you will take it as L plus L1 plus LP. LP we can take it as 1.25 into D. LP is nothing but piston length. Okay, LP is equal to 1.25 D. 163 plus 32.6 plus 1.25 into 130. Substitute all the values, you will get the length of the cylinder. Okay, next thickness of cylinder wall. Thickness of cylinder wall is equal to T. Assume allowable constant C is equal to 4 mm. thickness of cylinder wall. Okay, how we will find out the thickness? T is equal to is just available in the paper book. Don't be confused. Okay, T is equal to P max into D by 2 sigma all R. 2 sigma allowable stress plus C. Substitute all the values, you will get the T value. T is equal to 10 mm. Okay, next thickness of cylinder flange. Thickness of cylinder flange is TF. TF is equal to, we can take it as 1.3 into T. T here T is nothing but thickness of the cylinder wall. Okay, L 1.3 into T. 1.3 into T is nothing but 10 mm. TF is equal to 13 mm. Next, thickness of cylinder head. Cylinder head is nothing but the topmost position of the cylinder is called as cylinder head. Next, TH. Cylinder head is thickness of the cylinder head is termed as TH. TH is equal to KD root of P max by sigma allowable. Okay, KD root of a maximum pressure by allowable stress. K is nothing but we are taken as 0.35 into D 130 into maximum pressure 3.2, allowable stress 40. Substitute all the values, you will get the thickness of cylinder head at TH is equal to 13 mm. Okay, number of studs. Number of studs is nothing but N, capital N. Okay, it is in the range of 0.01 T plus 4 NS. NS is equal to, we can take it as 0.01 T plus 4. Substitute, you will get the NS. Okay, let us take N is equal to 6. Oh, next, seventh one, diameter of studs. Diameter of studs is nothing but the core diameter of studs is given by DC. DC is equal to D root of P max by N sigma TP. D is nothing but diameter, maximum pressure, N number of studs, allowable bolts. Okay, bolts is allowable stress. Okay, DC is nothing but core diameter of studs. Core diameter is nothing but when we fixed the two types of bolts, the difference between the length between the two diameters is nothing but the core diameter of the structure. Okay, DC is equal to D root of P max by N sigma PP. D is nothing but 130 mm. Maximum pressure is nothing but 3.2. N6 sigma TB 70. It is nothing but 11.34. Next, the nominal diameter of stress is dB is equal to dC by 0.84. Okay, now 0.84. DC is nothing but 11.347 by 0.84 is nothing but 13.5 mm. Okay, the nominal diameter of studs should not be less than 16 mm. The nominal diameter of studs should be not less than 16 mm. Then dB is equal to 16 mm. Okay, diameter of stud pitch circle and flange. dP and d naught. Diameter of stud pitch circle and flange. The diameter of stud pitch circle of is dP is equal to 3 dP. Okay, substitute all the values, you will get the dP value. Okay, okay. Let us take n is equal to 6. Diameter of structure ds. The core diameter of structure also we can take it as like this. Okay, the outside diameter of flange is d naught. D naught is equal to dt plus 2 dp plus 12. dp is nothing but 172 plus 2 into 16 plus 12. We will get the D naught value. Okay, pitch for studs. The pitch of stud is PBO is equal to pi dp by n. PBO is equal to pi dp by n. It is nothing but pi into 178 by 6. PBO is equal to 93.2 mm. The minimum and maximum permissible values of which are PBO, అంటే minimum and maximum permissible values. Permissible values means minimum permissible values for bolts, maximum permissible value for bolts they will given. Okay, now we can write it as a 9. Why we can write it as 19 and 28 means in the data book for the cylinders there will be given an value. Okay, this value you should write out that value only. Means that's why we are taking the 19 root dB, 28 root dB. Substitute if you, the maximum pressure should be the highest value. If it has a lowest value, it is not satisfied. Maximum pressure is the highest value, then it is satisfied to keep the bolts in the cylinder, valves and flange. Okay, this is the problem which we are discussing about the design of cylinder. In the last class also we have discussed one more problem. Okay, one more problem in the last class also. Just to practice these two models, you will get the cylinder. Don't be confused about the formulas of which we are taking. Just to keep the procedure correctly, the formulas will be in the data book only. Okay, that's why you purchase the data book or you take from your seniors. Okay, you keep it with you. What is the procedures next step? They only they will give given in the data book only. Just you write the formula and substitute those values only. Okay, it is very easy to solve the problems. Okay, this is the problems which we are discussing about the design of the cylinders. Okay, first we had discussed about the design of cylinders. Next, in the next class we will discuss about the piston and the piston length and design of the piston also. Okay, this is very important topic, how we should design the each and every part of an IC engine. Okay, how should we design, and how much length we should take, and how much bolts we should take, studs we should take, a flange, how thickness we should take, all the design process only they will give. We will see in the design process. Okay, first you practice design process, then you will get the easily the problems. Okay, na? Okay, first you should practice about the design about the cylinders. Okay, in the previous before classes I have told the design procedure of the cylinders. Okay, like that you should practice a step first, you will get the design of the cylinder processor. Okay, next class we will discuss about the piston and the number of design of the piston. We will practice. Okay, if you have any doubt, you please contact me. I will tell each of every procedures with you. Okay, and I will keep the material in the drive also. Just you go through the material and you will easily identify. Just you take your book and write down the problem. First you write down the problem, then you will get easily step by step. Okay. First you write down the problem and what they have given in the given data. Just you write it. Okay. If you write it the given data, automatically what should we find out, we can easily identify. If you see me like this, you cannot practice anything. Okay. In this problem, we should practice the cylinder bore. Okay, as we discussed about, we should find out the bore and stroke of engine, thickness of the cylinder, size and number of the bolts. In this size and number of the bolts, we should calculate the pitch of studs and also diameter, outer diameter of studs. Also, we should find out. Okay. Okay, we should find out like this. If you have any doubts, please contact me. I will explain each and every problem to you. Thank you, students.